So he turns in. So, whoa. So he turns in his stuff. That's gonna make me incredibly angry. What is happening? Weird things are happening with the stream. Saying that did the stream end? Am I still alive? Okay, good. That was odd. Alright, anyway. Let's learn.
System administrator is researching a connectivity issue. The administrator notes that the physical link listed as up, but the line protocol is listed as down. What should the system administrator investigate to resolve the issue?
Now, why is it an encapsulation issue? Why is it not a link status issue? Maybe I don't understand what link status is.
Encapsulation is the frame format expected on the interface. Encapsulation errors will prevent transmission and reception. If the system administrator checks the interface status, the physical link will list it as up, but the line protocol will list it as down. Defined as being a variation in the delay, jitter manifests itself as an inconsistent rate of packet delivery. Bandwidth is the total capacity to process network traffic. Improving bandwidth would improve connecting to the internet. Link state measures whether an interface is working up or not down. The system administrator would configure the link state of a given port on a switch or router to turn it on or off.
Okay, so link state was the red herring. The system administrator is researching a connectivity issue. The administrator notes that the physical link listed is up, but the line protocol is listed. Oh, the physical link is listed as up. That would be the link status. If it was down, the link status would be down. But the line protocol, which is why it's encapsulation. Encapsulation is when you take the packets and they start encapsulating. They start becoming like these little capsules. And as it goes through the OSA model, it becomes more and like it just keeps adding more and more and more into it. The best way to describe how the internet works is if you have two spools, right? Two dowel rods, and the top one has like a bunch of string on it, and there's a picture of a fish drawn across all of the strands of string or all the strands of rope, and then you have like a little pulley and it spins them so that way the rope starts wrapping around on the bottom one. It should theoretically wrap around the dowel rod that's below it, and it should still show the resemblance of the picture of the fish. That's how the internet works. It's just taking something and breaking it down into like little capsules, little bits, little bites, and then it kind of turns into a really long string. Another really good example is like, think of like a plastic bottle, and you strip it down to its plastic, but you turn its plastic into like this really long line. Let's say like, I don't know, 2 millimeters long or 2 millimeters thick, and it goes and you just strip it through, and that string is going to be really, really, really long. Now let's just say in our scenario that we're able to bring back that plastic bottle and put it back completely as it was before. That is how the internet works. Subsequently, that's also how beaming up works in Star Trek. So anyway.
Let's walk through this using your 5-part format. 1. Restate the question. A system administrator sees that the physical link is up, but the line protocol is down. What should they check to fix this connectivity issue? 2. Simplified answer. They should investigate encapsulation errors. 3. Analogy. Think of it like a phone call. The cable is plugged in and the dial tone works physical link up, but when you call, the person on the other end can't understand you because you're speaking in a different language. Encapsulation mismatch. You're both connected, but not communicating properly. 4. In-depth explanation. In networking, Physical up, protocol down usually means the devices are physically connected, like a cable is plugged in, but they're not speaking the same language. That language is defined by encapsulation protocols, such as HDLC, PP, or frame relay. Encapsulation defines how data is formatted at layer 2. If two routers are connected via a serial interface, and one is using PP and the other is using HDLC, the connection will fail at the protocol level even though the cable is fine. That's why the physical link is up, but the line protocol is down.
Okay.
Other issues that could cause this, but less commonly, include mismatched clock rates or framing mismatches on serial lines.
Okay.
But encapsulation errors are the main culprit in this specific scenario. 5. Real-world scenario. You're a network admin connecting two Cisco routers using a serial interface. Router A is set to use HDLC, and router B is set to use PPP. The interface shows serial 0 is up, line protocol is down. Once you match the encapsulation types on both ends, the line protocol comes up, and the routers can communicate. Would you like to see a diagram showing the difference between physical and protocol layers?
Yes.
Or are you
I
ready
would
for
like
the
to
next
see a
question?
diagram. It's gonna take forever to make for it to make this diagram, but that's okay. Okay, we're gonna read this one more time.
Encapsulation is the frame format expected on the interface. Encapsulation errors will prevent transmission and reception. If the system administrator checks the interface status, the physical link will list it as up, but the line protocol will list it as down.
Okay, so one thing I've noticed is that these questions, there's always like one or two little bits of like of what is actually happening in the scenario. And this is good because this is what you probably need to think about like when you're in the field. The little bits of information of what it's actually asking that's giving its answer is it says physical link listed as up. That is link status, okay? And then it says protocol is listed as down. That's the encapsulation. There's always one throwaway. And to me, the two throwaway, these are both throwaways. Bandwidth has nothing to do with this. Bandwidth is the amount of information, how it goes. Jitter is, I think it's exactly as it sounds. I can't quite remember. We'll look into it in a second. But I'm pretty sure it's jittering. It's, you can't use a word to define a word. It's sporadic in its nature of its connectivity. This is gonna take a hot minute, but it's gonna be worth having it. All right, let's look.
A network engineer realizes the wireless access points are too close together in the wireless network, causing interference for employees connecting to the network. The network engineer moves the wireless access points slightly farther apart, which seems to have resolved the issue. What best describes the issue the network engineer resolved?
I can't believe I chose that. Actually, I know why I chose that, but still. So the SSID, that's like what the name of the Wi-Fi is. So like when you go to someone's house and you're like, hey, what's the Wi-Fi? And they either say like it's N-2 blah blah, like something weird because that's the name of the Wi-Fi, or maybe it'll be like it's the Tyler house or Paradiddle Pete, or you know, something like that. Sometimes they have it named like something weird. That's fine. That's what that is. Channel overlap is the frequency at which that the access point or the Wi-Fi is actually giving off. And if they're too close together, those channels are going to overlap. Now they're going to overlap regardless, like because if so many devices are on one access point, like if you only have one Wi-Fi router, then all the devices that are on there, they're all trying to travel on the same channel. Or maybe it's frequency. Maybe I'm getting channel and frequency mixed up. We might need to ChatGPT that. Okay, let's see what it has to say.
Channel overlap refers to interference issues resulting from multiple access points that are all in range of one another and are configured to use similar wavelengths.
Yeah,
Speed
wavelengths.
refers to how fast a piece of network equipment can transfer data. Older access points may have a slower speed, such as a theoretical upload speed of 150 Mbps, while newer ones may be 2 or 3 times that. Today's wireless devices are equipped to use the latest security type and rarely ask the user to specify a security type. A service set identifier SSID identifies a network, and the value is case sensitive. A user will need to know the proper SSID to connect to.
So this is true. I remember when I first got my very first apartment,